page 93, we'll start to learn linear models. Okay, linear models. First, we look at what is the slope of a linear model. Okay, so linear models in general has a form of y equals mx plus b. Okay, so we'll talk about the slope of the linear model, which is what? The m value. Okay, so now let's look at these examples and then we understand what is the slope of the linear model. Okay, so we have the milk problem. I will give you some time, okay, a couple minutes to read these two graphs and try to answer question 1 to 4, and then we'll talk about them. Okay. Okay, so let's try to answer these questions, okay? Question 1, where does each graph begin? See, this line begins from here, this line begins from here. So, 0, 0, okay? Yeah, because from this point, these points in the graphs, okay, we start from origin. Origin has coordinate 0 and 0, okay? What does the 0, 0 mean? Means, if we're not buying any gallons of the milk, do we have to pay? No. Okay? So the meaning is if we purchase 0 gallon of milk, okay, we should spend $0. Makes sense, right? We don't buy and we don't have to pay, right? Okay, question 2. These two graphs have the same scales on both x and y axis. What are the x-axis? X-axis give us what? Number of gallons of the milk purchased. Okay, so this 0 means 0 gallons we buy, then we don't buy anything. This means what? If we buy 1 gallon of the milk, we buy 2 gallons of milk, 3, 4, and so on. Same thing here on the other graph. If we buy 1 gallon, how much we should pay? If we buy 2 gallon, how much should we pay? And so on. Okay, so that's why also on the vertical axis, okay, it gave us $5, $10, and then until $45. Same scales. Okay, from both graphs. But let's look at these two straight lines. Which straight line looks more steeper? Do you understand steeper? Yeah, steeper. This one looks more steeper, right? This is more flatter, right? Flatter in this way. So this is more steeper. Why? Do you understand why? Same skills, right? Why this second one looks more steeper than this? This is graph for what? 2% milk, regular 2% milk, okay? This is what? For organic milk. Now let's look at the graph. If we buy 1 gallon of the regular 2% milk, how much do we pay? $3.30. How about the price if we buy 1 gallon of the organic milk? About, I would say $6 something, okay? Yeah, $6.49, okay? And then we buy $2 gallons, and then this regular one only costs $6.6, but this, organic one will cost what? $12.98, okay? So that's why. The reason is because what? Organic is more expensive than what? Regular 2% milk, okay? So we answer that organic milk is more expensive than what? A regular 2% milk, okay? Then the regular how much is a gallon of a 2% milk? How much? 3.3. How did we determine that? From the graph, right? See, when x equals 1, y equals 3.3, right? So that's how we figure that out. How much is a gallon of organic milk? Every 1 gallon give us what? $6.49. Right, guys? Okay. I believe these are the first 4 problems. So I hope everybody is clear about these questions. Okay, now I'm going to ask a volunteer to read the entire left part, left over from page 93. Whose turn? Armando?
Yep. Notice 649 is greater than 330, and as a result, the organic milk line is steeper than the 2% line. The steepness of a line is commonly referred to as the slope of the line. The slope is simply the unit rate of change, in this case, the cost per 1 gallon of milk. The slope, often called m, of a linear model can be calculated from the ratio of absolute change in y to the absolute change in x. Slope represents the unit rate of change. If you don't already know the slope of a linear model, you can calculate using 2 points information, using 2 points from purchasing gallons of organic milk. Correct.
Okay, very good, thanks. Yeah, so slope is simply the unit rate of the change, okay? In this case, the cost per 1 gallon of the milk, okay? And the steepness of the line, straight line, give us what? Refers to the slope of the line, okay? So if we say this line is more steeper than this one, we say this line has a bigger slope, okay? Yeah, larger slope, okay? Yeah, bigger slope, okay? And then to compute the slope, okay? Okay, slope can be computed by what? Ratio of the absolute change in y to the absolute change in x. So if we compute the slope, okay, absolute change in y divided by absolute change in x, and then it's also we can use the cost per gallon, okay, cost per gallon. So because for every 1 gallon of the milk, organic milk, okay, it will cost us $6.49, right? So we use the price, okay, per 1 gallon, which is unit price, okay, or unit rate, whatever. That gives us the slope of that straight line in the second graph, okay? So what is a slope? It's what? $6.49 per gallon. You guys? Okay, so to create a linear model, okay, first we need to figure out what is the slope of the line, which is the steepness from the line. Then we need to look at what? The b value. Okay, once we get both m and b, we just need to use this form so we can get a linear model. Okay. All right. Next page. 94. Okay. I will read this part for us. Okay. let's assume that we're going to the store for more than just the milk. We have already bought something, a cart full of groceries. The last thing on the list is the milk. Okay, notice how the additional purchases impact our graph. Okay, so just that, this 2% milk, regular one. Okay, so before we start to purchase the milk, buy the milk, we've already has what? A $50 groceries in our cart already. So where does this line begin? 54. Yes, very good. 54. Okay, you're right. $54, not $0 anymore. Okay, because we already got stuff. Okay, in our cart. What does this mean in the context of our purchase? We have already talked about it, right? These $54 are from what? Other groceries, okay? Because these $54 are from the other groceries. Right? Already, before we buy the milk. Okay? Well, this value, okay, yeah, we call it is a y-intercept, or often b value for us, okay? I'm going to ask another volunteer read this gray box for us. Even?
The y-intercept, often called b, is the point at which the graph crosses the y-axis. B is also the y value that corresponds to an x value of 0. B represents the starting value for the model.
Okay, very good. Yeah, because this $50 is our starting value, okay, for y, okay, and also we can see that, this is the point when the graph intersect what? Crosses or intersect the y-axis, okay? So this point we call it is a y-intercept, okay? Y-intercept often called value b, value b, okay? So questions 3 and 4, what is the y-intercept or b of this model? What is that? $54, right? And what was it? Y-intercept will be when we were only purchasing milk on the previous page. What was the y value? $0. Yeah, you guys. Okay, good. Now, constructing the linear model. I use emphasize the mark here means you have to know how to constructing a linear model. Okay, so just now we talked about what? Slope. Okay, steepness of the line. Also, we talk about as a starting point on the y-axis, which is the y-axis, right? Then the linear model is defined by this. Okay, a volunteer read this part for us. Chris?
Linear models are equations that can be used to predict outcomes of the independent or dependent variable. Models created by Excel are most often in slope-intercept form. Y equals mx plus b. Amount equals unit rate, which is the quantity, plus starting value. This is commonly written in slope-intercept form. Y equals mx plus b.
Okay, very good. Thanks. Consider the graph at the top of the page. Okay, we're using the example from this page. Okay, what is the slope of this line? What is the slope? What is the unit price for the 2% milk? Do you still remember? We did it. $3.30, right? So M, which is a slope, is $3.30. What is the y-intercept? $54. Okay, so can we build a linear model, or can we construct a linear model for purchasing this 2% milk? Yes or no? Yes. So y will equals what? 3.3 times x plus what? 54. Oh. You got it. So this is the key, okay, for section 8. Okay, scatter plots, you understand those points, they give you our x values, what is that, and y value, what is that, okay? And then construct linear models, okay? All right, so on page 95, okay, yeah, let's do the entire page of page 95, okay? Sometimes the slope m is positive, right? Remember the milk problem? We'll have what? Increasing lines. Sometimes the slope m may be what? negative. That means your C will have what? Decreasing graph, okay? So from this weight loss problem, okay, I'm going to ask the volunteer to read the question and question A and B, okay? Question 1, A and B. Oh, let me see. Question 1 has A, B, C, D, right? A student to read the entire question 1. Morgan?
David weighs 240 pounds and sets a weight loss goal of 2 pounds per week. Let X represent the number of weeks on a linear model which represents how much David hopes to weigh after X weeks of the plan. What will the dependent value Y represent in our model? What units will Y be measured in? What will the independent variable X represent in our model? What units will X be measured in? Where will the Y-intercept be the starting point? What is the slope and the rate at which Y changes when X increases by 1 week? Is it increasing or decreasing? Put the pieces together to write the model X equals mx plus b, or Y equals mx plus b.
Very good. Thank you so much. Okay. So the first question, eventually we will be able to create a linear model. Okay. So Dave weighs 240 pounds and then he wants to lose some weight. By a plan. What plan? Every week lose 2 pounds. That's his plan. Okay, now let's answer these questions, okay? What will the dependent variable Y represent in our model? Okay, it says, find a linear model represent how much Dave hopes to weigh after X weeks of the plan. So we can also start from question B. What will the independent variable X represent in our model? Weeks, right? Yes, very good. Weeks, okay? Times, okay, or on diet in weeks. Okay, I'm going to write it this way, okay? Time on diet in weeks. Alright. What will the dependent variable Y represent in our model?
Weight.
Weight, yes, right. Weight in pounds, okay? Weight in pound. In pounds. Yeah. So when X variable, this independent variable changes, okay, when time flies, okay, goes by, how much weight will, they weigh, okay? What is the Y-intercept, or B? Or the starting point? What is the starting point? 240 pounds. Okay. What is the slope M in this problem? By each week, Y, the change of Y should be what? The weight of his should be, goes up or down?
Down.
Go down. So slope M equals what? If we say B equals 240 pounds, and M should equal what? -2. Okay, or you can say pounds per week, whatever. Or you don't have to put a unit. So M equals -2 means he planned to lose 2 pounds per week. Okay, so can we put these pieces together? Y will equals what? -2 times X plus 240. Yes, this is so important, okay? Because with the equation, we'll be able to do the calculations. You guys was good for the line, for the model? Okay. Question 2 and 3. How much does David hope to weigh after 4 weeks? This X gives us weeks, right? So after 4 weeks, we should replace X by what? 4, right? So Y should equals -2 times 4. We replace X by 4 plus 240. Have you got it, your answer? -8, 240. What? 232, right? Pounds, okay, pounds. How much does Dave hope to weigh after 10 weeks? Replace X by what? 10? What's your answer? 220, right? Question 4. how long would it take Dave to reach his goal with a weight of 180 pounds? Asking for how long, so it asks for X for Y. X. If the weight equals what? 180. So what do we do? We replace Y by what? 180, yes. Now how do you solve for X, guys? How do you isolate X? This is a linear equation. In order to isolate X, first we're going to subtract 240 from both sides, right? Left hand side, 180 minus 240, negative 60 equals negative 2x. Then what do? Divide by negative 2. So x will equals what? 30. Means after what? 30 weeks, Dave will reach his goal of what? 180 pounds. If he could make sure that he can lose weight for 2 pounds per week. Keep on doing that. It's really hard. If you, some people just, they can lose weight quickly for a couple of weeks, like a couple, several weeks. Then they stop losing weight. It's so hard, okay? See, it will take like 30 weeks for him to lose from 240 to 180, 60 pounds. Too much. Okay, so complete, there's a graph of David's plan, okay, below. Okay, so if we're going to draw a picture when x is 0, which is, initially, he started, he was 240 pounds. After 1 week, he lose 2 pounds, he should be what? 248 pounds, right? In 2 weeks, he lose 4 pounds, he should be 236 pounds, right? So every week, lose 2 pounds. So can you imagine? So if we draw the graph, it's going to look like this, right? Straight line, and it is what? Decreasing, right? Briefly. Yeah, just draw it briefly. Question 6 and 7. If Dave were to risk his weight loss goal to 3 pounds per week, he wants to lose 3 pounds per week, how would the model and the graph change? How would the model change?
The line would be steeper.
Yeah, see, previously lose 2 pounds, that's negative 2. Now he wants to lose 3 pounds, so it's going to be y equals negative 3x times plus what? 240, right? So y equals negative 3x plus 240. And how will the graph change? When x equals 0, y is what? 240. When x equals 1, y will be what? 237. So this new dot should be below the previous one, right? When x equals 2, y will be 234. Okay, another point, red point, which is below the previous one, because he looks more, right? Looks more. So the new graph should look like what? More steeper in a negative way, right? Okay. So, yeah. So how would the model? How would the graph change? Is the slope of the line becomes steeper in the negative direction. Okay. You're gonna answer it. Okay. Question 7. Is it reasonable to assume Dave would stick to this weight loss indefinitely? Yes or no?
No.
No, he only has 240 pounds. So he must have some weight. He cannot have a 0 pounds, weight in 0, right? So this is just like he will lose some pounds, but he cannot do it indefinitely. So answer is no. Okay. Okay.